Parallelism is great until you hit your database with 1,000 concurrent requests. This is the fan-out trap. Use a concurrency limiter like plimit to batch your requests and keep your infrastructure stable. In modern development, we rarely talk to just one database. We talk to an auth service, a CMS, a payment gateway, and perhaps a third-party API. Every await in this chain is a synchronous block in an asynchronous world. If the auth service is slow today, every other part of your request is held hostage. This doesn't just affect the user's perceived speed, it affects your server's resources. While a function is awaiting, it's holding onto memory, keeping a socket open, and staying in the execution context. Under heavy load, these parked requests accumulate, leading to memory pressure and eventually service exhaustion. You aren't just slow, you're inefficient.
The primary antidote to the waterfall is concurrency. In JavaScript, this is most commonly achieved via Promise.all. Instead of awaiting each promise individually, we initiate all of them simultaneously and then await the collective result. Look at the timeline now. Our 3 100-millisecond tasks are now running in parallel. The total time spent is no longer the sum of all tasks, but simply the duration of the single slowest task. In our example, we've cut the response time from 300 milliseconds to just 100. We haven't changed the speed of our services. We've simply stopped wasting time waiting for things that don't depend on each other.
However, there is a second trap, over-concurrency, or the fan-out problem. If you have a loop that processes 1,000 items and you use Promise.all to fetch data for all of them at once, you aren't just being fast, you're launching a self-inflicted denial of service attack against your own database. Every database has a connection limit. Every API has a rate limit. By firing 1,000 requests in a single millisecond, you will likely trigger timeouts, socket hangups, or circuit breakers. This is where many developers revert to sequential awaits out of fear, but there is a better way. We need to move from one at a time or all at once to a controlled middle ground. The professional solution is controlled concurrency, often implemented via a limit or pool. Instead of 1,000 at once, we process in batches of, say, 10. Libraries like plimit or Bluebird allow you to define a concurrency threshold. This gives you the best of both worlds. You saturate your available bandwidth and keep the database busy without overwhelming it. You maintain high throughput while ensuring system stability. When designing your async logic, always ask, do these tasks depend on each other? If not, how many can I safely run at once? Setting a default concurrency limit for bulk operations is one of the simplest ways to make your application both faster and more resilient.
Async-await is a tool for readability, not a directive for execution order. First, identify independent tasks and group them using Promise.all or Promise.all settled. Second, for large loops, never use a naked Promise.all. Use a concurrency limiter to protect your infrastructure. Third, remember that await is a pause button. Use it intentionally, not reflexively. By breaking the waterfall habit, you'll build applications that are snappier for users and more efficient for your servers. High performance in JavaScript isn't about writing complex code. It's about understanding when to stop waiting. Thanks for watching and happy coding.